Brace yourself, because what you're about to learn will completely change the way you see our universe. Picture a ring system so immense, so mind-bogglingly expansive, that it makes Saturn's iconic rings look like mere threads in comparison. Imagine a ring system so vast that if it encircled Saturn, it would dominate our night sky, stretching across the heavens and outshining even the brilliance of the full moon. Sounds like science fiction, right? But this is no fiction. This is the reality of J1407b, a distant exoplanet whose ring system is so colossal, it has left scientists stunned and rethinking everything we know about planetary rings. But before we leap into the far reaches of the cosmos, let's take a moment to appreciate the beauty of our own cosmic jewel, Saturn. For centuries, Saturn's shimmering, elegant rings have inspired astronomers and dreamers alike. It's no wonder Saturn remains one of the most admired and studied planets in our solar system. Yet what if I told you there's a contender that could overshadow Saturn's splendor? J1407b is unlike anything we've ever seen. A planetary system that pushes the limits of what we thought possible. Imagine rings 200 times larger than Saturn's, stretching so far they'd be visible even with the naked eye from Earth if they were here. So, what makes these two celestial giants, Saturn and J1407b, so unique? What secrets are hidden within these rings that have fascinated scientists for years? Join me on this cosmic journey as we unravel the mysteries of these otherworldly wonders and explore how J1407b might just claim the title of the King of Rings. Saturn, the sixth planet from our Sun, needs no introduction. Adorned with dazzling rings that shimmer against the blackness of space, Saturn is more than just a planet. It's the crown jewel of our solar system, instantly recognizable and awe-inspiring. For centuries, Saturn has held humanity's gaze, sparking wonder and curiosity. Since ancient times, we've looked up at this distant giant, fascinated by its golden hue. But it wasn't until the 17th century, when Galileo first pointed his telescope skyward, that we glimpsed Saturn's true beauty, its magnificent rings. Imagine the excitement of that discovery. Galileo's early observations revealed something no one had ever seen before. A planet with ears, as he first described it, not yet understanding he was looking at the rings. The revelation sent shockwaves through the scientific community and triggered debates and speculations that continue to this day. But what exactly are Saturn's rings? While they appear as solid ethereal bands up close, they are far more complex. These rings are made up of countless particles, each orbiting Saturn like tiny moons. These particles range in size, from grains of sand to chunks as large as houses, each one reflecting sunlight, giving the rings their stunning glow. Where did these particles come from? Scientists believe they're the remnants of ancient comets, shattered asteroids, or even moons that wandered too close to Saturn and were torn apart by its immense gravity. Now, these icy fragments are trapped in a delicate dance, endlessly orbiting the gas giant, colliding and interacting in ways that create the complex, ever-changing structure we observe. Saturn's rings are not just beautiful, they're scientifically fascinating. They offer a miniature glimpse into the past, like a time capsule from the early days of our solar system. Much like the disk of dust and gas that once surrounded our young sun, these rings give us clues about how our solar system formed billions of years ago. By studying Saturn's rings, we're not just admiring their beauty, we're unlocking secrets about the creation of planets, moons, and even the Earth itself. Saturn's rings offer us a unique window into the past, the present, and possibly the future of our cosmic neighborhood. Who knew that these stunning rings could hold so many answers to the mysteries of our universe? Now, let's turn our attention to the enigmatic J1407b, a planet located approximately 434 light-years away in the constellation Centaurus. This distant world, first discovered in 2012, has sent ripples of excitement through the astronomical community. Why? Because J1407b possesses a ring system so extraordinary, so utterly massive, that it makes Saturn's rings look like mere trinkets in comparison. J1407b is a gas giant, estimated to be several times more massive than Jupiter. However, what truly sets it apart is its colossal ring system, spanning a staggering 200 times the diameter of Saturn's rings. To put that into perspective, if J1407b were placed at the center of our solar system, its rings would extend far beyond the orbit of Mars. These rings are so immense that they were initially mistaken for a circumstellar disk, a ring of material surrounding a star. The rings of J1407b are believed to be composed of dust and gas, similar to Saturn's rings, but on a much grander scale. Their sheer size suggests that they are relatively young, perhaps only a few million years old. This makes J1407b a prime target for studying the early evolution of planetary ring systems. As J1407b continues to orbit its star, its rings will evolve, potentially coalescing to form moons or being gradually eroded over time. By observing these changes, astronomers hope to unlock the secrets of ring system formation and evolution. Comparing the ring systems of Saturn and J1407b is like comparing a delicate snowflake to a raging blizzard. Both are captivating in their own right, but their sheer scale and nature make direct comparisons a challenge. Saturn's rings, while vast, are relatively thin and composed mostly of icy particles. J1407b's rings, on the other hand, are monstrous in size, encompassing a much larger volume of space and likely containing a greater diversity of materials. The distances involved also pose a significant obstacle. Saturn, residing within our own solar system, can be studied in exquisite detail by spacecraft like Cassini. J1407b, however, lies hundreds of light years away, making direct observation of its rings impossible with current technology. Astronomers rely on indirect methods such as observing the dimming of J1407b's star as its rings pass in front of it to infer the properties of its rings.